Consciousness, the state of being aware of ourselves and the world around us, remains one of the most profound mysteries in science. How does the brain, a complex network of billions of neurons, give rise to subjective experiences, thoughts, and feelings? This question has puzzled philosophers and scientists for centuries. Traditional neuroscience, with its focus on neuronal activity and brain regions, has provided valuable insights into the biological correlates of consciousness. However, a complete explanation for how subjective experience arises from objective physical processes remains elusive. In recent decades, some scientists have turned to the strange and counterintuitive world of quantum mechanics for potential answers. Quantum mechanics, the theory governing the behavior of matter at the atomic and subatomic levels, is known for its mind-boggling phenomena such as superposition and entanglement. Could these quantum phenomena, often confined to the microscopic world, also play a role in the macroscopic realm of the human brain? Quantum physics, with its inherent uncertainty and non-locality, challenges our classical intuitions about the nature of reality. It introduces the concepts of superposition, where particles can exist in multiple states simultaneously, and entanglement, where two particles become linked and influence each other instantaneously, regardless of distance. Recent discoveries in quantum biology have revealed that quantum effects may play a more significant role in living systems than previously thought. For instance, photosynthesis relies on quantum coherence, a delicate state where particles act in unison. Similarly, there is evidence suggesting that birds may use quantum entanglement in their retinas to navigate during migration. Could it be that the brain harnesses the power of quantum mechanics to achieve its remarkable feats of information processing and consciousness generation? While the idea remains speculative, it has gained traction in recent years, leading to the development of several intriguing hypotheses. The Orchestrated Objective Reduction, OR model proposed by Sir Roger Penrose and Stuart Hameroff is a prominent quantum theory of consciousness. It suggests quantum computations occur within microtubules, tiny structures in neurons. These microtubules act as quantum computers with states in superposition. Quantum computations may orchestrate neuron activity, leading to consciousness. When quantum coherence reaches a threshold, objective reduction occurs, creating conscious experience. Another intriguing hypothesis proposes that entangled photons, particles of light that are quantum mechanically linked, could play a role in neuronal communication and consciousness. This hypothesis, put forth by physicists Zefei Liu and Yongkong Chen, along with biomedical engineer Ping Ao, suggests that the myelin sheath, a fatty layer insulating nerve fibers, could act as a waveguide for entangled photons. According to their model, vibrating carbon-hydrogen bonds within the myelin sheath could generate entangled photons. These entangled photons could then travel along the myelin sheath, influencing neuronal firing at distant locations. This non-local communication could potentially contribute to the synchronization of brain activity, a phenomenon thought to be crucial for various cognitive functions, including consciousness. However, further experimental evidence is needed to confirm the existence and function of entangled photons in the brain. Despite the growing interest in quantum biology and its potential implications for consciousness, many scientists remain skeptical. The main challenge is explaining how quantum coherence could be maintained in the brain's noisy environment. Quantum coherence is fragile and easily disrupted by decoherence. Critics argue the brain is too hot, wet, and noisy for quantum coherence to persist. Even if maintained, it's unclear how quantum effects scale to consciousness. Consciousness involves integrating information from various brain parts. These challenges don't rule out quantum effects in consciousness. The question of whether quantum mechanics plays a role in consciousness remains one of the most tantalizing and challenging frontiers in science. While the brain's warm, wet, and noisy environment poses significant challenges to the preservation of quantum coherence, recent discoveries in quantum biology have shown that quantum effects can indeed persist in living systems. The hypotheses proposing a role for microtubules and entangled photons in brain function, while speculative, offer intriguing avenues for further investigation. Future research using advanced imaging techniques and sensitive detectors may be able to detect and characterize these quantum phenomena in living brains, providing crucial evidence for or against their role in consciousness. The pursuit of understanding consciousness will undoubtedly require a multidisciplinary approach. drawing on insights from physics, biology, neuroscience, psychology, and philosophy. By combining theoretical modeling with experimental validation, we may one day unravel the secrets of consciousness and its relationship to the quantum world. And within our own brains, perhaps, lies the greatest scientific mystery of all, waiting to be unlocked.